Hi, everybody. Thank you very much for coming to tonight's workshop. I'm Kyle Damerel. I'm the Technology Director here at UTDL. At UTDL, we host the numerous workshops from different CAD programs, Arduino-based, simulation, and 3D printing. Today is our Fusion 360 workshop. It's a special one today as it is sponsored by Autodesk, and we have a Fusion 360 expert here, Gabby, to do and host the workshop today. Our workshops are all about going from the digital workspace to the physical workspace, getting you ready to get through and create different objects within the CAD basis and that digital workspace, then going through and making electrical components in Arduino, 3D printing, and putting it all together to make that first awesome prototype. It's all for real world scenarios, different class projects, and to get you ready for our design-a-thon that we'll be hosting at the beginning of February. So thank you all for coming, and Gabby, I'll hand it off to you. Thank you very much for coming today.
Sure. Welcome, everyone. Yeah, so I'll introduce myself. So I'm Gabby Waldman-Fried. I work at Autodesk, and my role is on the education team. So I used to travel a lot. I used to go to U of T a fair bit, but now I'm at home. But I interface with universities all over the country, supporting them in using Autodesk products, mainly Fusion 360. So yeah, work with a lot of students, a lot of professors, a lot of manufacturing staff, so in machine shops and things like that, because Fusion is a big manufacturing platform as well. So yeah, that's my role. It's a lot of fun, and I get to do these workshops with y'all. So here we are. So today we're going to talk about Fusion, kind of the overview of the program, and we're going to do a hands-on workshop with CAD. So if you all have Fusion installed already, please boot it up. And if you don't, I'm going to put a link in the chat, and you can go to that website and create an Autodesk account and download Fusion. So I will, second. So just a show of hands, the easiest way to do this is to put a yes next to your name. So if you click participants on the bottom of the Zoom panel, you can put a reaction in. So who has Fusion installed? Can you put a yes next to your name? Okay. Only 4 of you, 5 of you. 1, 2, well, some people put a thumbs up. 1, 2, 3, 4, 5. Okay. So seems like most of you, well, some need to download it. This is going to be a hands-on workshop, so if you want to be part of that hands-on portion, you will need a Fusion. If you have any questions at any point as you're creating it, I'll get to them. All right. I'm going to clear answers, and I'm going to ask, which is who has used Fusion before? Can you put a yes in the participants list? Okay. A good amount of you, about half. Nice. Okay, sweet. Good to know. All right, let's get started here. Great. All right, can you all see the presentation? Yes?
Yep.
Yep, great, thank you. Okay, so this is a little sneak peek of what we're going to be creating. So let's go. All right, so this is very important. So with virtual workshops, it's really hard to, ask people to follow along because they can't look at what I'm doing and what they're doing at the same time if they only have one screen. So I really try to do basically a lecture demo follow or lecture demo try format. So first I'm going to talk a little bit, and then I'm going to do a demonstration, and then I'm going to pause and give you time to try it on your own. So do not feel like you have to do the thing I'm doing while I'm doing it. That's really hard to do virtually. So I will pause and give you time to do that step. So hopefully that helps the flow a little bit. If you do have multiple monitors and you can do it at the same time, you're free to, but if you don't have multiple monitors, it's nearly impossible. All right, so what is Fusion? So Fusion is an end-to-end platform for design and make, essentially. So it enables end-to-end product development. And what that means is that it basically tries to combine all of the workflows from different pieces of design stages into a single platform. And it was created kind of with the intention of filling in a huge gap in the CAD market, right? Which was that to do anything beyond, what your software could do, you had to export your data. And every time you exported your data, you lost information, right? Like if you export like your model as a step file or as an STL file, right? It basically dumbs down your model. It strips it of a lot of information into like, a solid format that is much more basic. And when you do that, you're losing time, you're losing intelligence, and it makes it really hard to make changes. So in a design cycle that you would see in industry, you really need to go through all of these phases. You need to CAD, you need to do optimization studies, you need to do analysis studies, and you need to do manufacturing studies. And you want to be able to do that without losing a lot of data and without losing a lot of time. You can imagine if you had a software that could only do CAD, and then a different one that could only do engineering analysis, and then a third one that could only do tool pathing for manufacturing. As soon as you export your data from CAD to CAE to CAM, you're losing time because you can't have those data models, you can't have those models connected. So if you have to make a change, you have to go back to the beginning, re-export, and then redo all of your work in those other softwares. So Fusion gets rid of those really fragmented workflows and enables you to do the entire product development process in one software. And the other really cool part of it is that it harnesses the cloud for a lot of things. So previously where you'd have to run a lot of things locally, it would bog down your memory and processing power to run renders or simulations. In Fusion, it all can be done in the cloud. And the other big piece of Fusion is that the data management is all in the cloud. So your files are stored essentially in your own Google Drive for CAD. So it's like your own hard drive, but in the cloud, and you can invite other people to collaborate with you inside your hard drive and share your files that way and work on group projects. Set different permissions for different people, which really smooths a lot of the kinks out when you're trying to share files. When I was in school, I used to have to like basically we'd share it by emails or USB drive. And then we get a lot of, crossed wires where we would, have different copies of the same file floating around. We didn't know which one was more updated. We couldn't all work on the files simultaneously, and it was a real pain. So this cloud data really enables a better workflow. And the last thing is that it can run on both Macs and PCs, which I find for engineering students, most are using PCs anyway, but good to know. All right, so talking about the end-to-end product development platform, Fusion has a lot of different workspaces that enable that. So we have a parametric design workspace, so sketching, 3D modeling, assemblies, engineering analysis, like we said, rendering, animations, motion studies, manufacturing, simulation, and of note here, we also have an electronics workspace. So you can take your mechanical models and create PCB boards with sketches that you've outlined or PCBs, and then you can populate those PCBs in a fully fledged out electronics workspace. It's basically Eagle. So if any of you have heard of Eagle, Eagle has been working on integrating it into Fusion. So all the capabilities you have in Eagle, which it's a full functioning electrical CAD program, are now inside of Fusion, and it's all parametric. So if you change you change your mechanical model, it'll change the board and it'll update, and you can push your electrical models back into the mechanical space and see the 3D models of all the board pieces. So really, really cool stuff there. There's also a Fusion on the web. So you can send links of your models and then people can view them on the web, things like that. You can comment, you can, share it that way also. And all of those comments that you would do on the web would come back and be attached to your models when you open them inside the software. What else is of note here? We also have Fusion available on Chromebooks. So you can run Fusion in a browser if you have a Chromebook as well. All right, there's something in the chat. All of Eagle's functions now in Fusion. Yes, it's awesome. As of this fall, probably September or so. Yeah. Okay. So next here. All right, so how to install Fusion. So about half of you have Fusion, but I put the link in the chat, right? Go to autodesk.com/education. Go under the start now, or whatever that banner says, get free software. You'll select the Fusion 360 kind of box, and it will prompt you to create an account, fill out an education profile, and access the software. And if anyone has any issues with that, let me know. Okay, so let's talk about data for a second. So, I mentioned how, Fusion stores your data, your CAD data in the cloud. But I just want to give you a little bit of a sense of what that looks like. So everyone is given a Fusion team when you create, when you log in with your Fusion account. Or with your Autodesk account. And that Fusion team is your hard drive. It's where your data is stored. Now, you can only have one Fusion team, but you can be invited into lots of Fusion teams. So if you're working on different projects with different people, or maybe your professor is using Fusion and has a team for their class, you can be invited into, as many Fusion teams as you want, but you only own one Fusion team. Now, all the Fusion teams have the same structure, and that is the Fusion team is the hard drive, right? You give it a name. Mine's just called Gabby's team or something. Under that, you have projects, and under that, you have folders. Now, these are just further, they get more granular as you go down, right? The reason that they're differentiated between projects and folders in that, not everything below the team is just a folder, is because projects give you permissions. And that's what the lock represents. You can, you can set permissions on the team level and you can set permissions on the project level, but you can't set permissions on the folder level. So what that basically looks like is like I can invite, Kyle into my Fusion team, and I can, and then Kyle can see all of my data. If I want, I can set what those permissions look like. Can he edit? Can he basically go in every project or just some projects? Does he get administrator access and things like that? And then on the project level, I can also set permissions. So I can say, oh, I only want certain people in certain projects or whatever. So that is really useful for managing your data. So you don't, you're not giving everyone access, and you can give people edit access, or you can give people view access, and you can really decide how you're sharing all your CAD data. Okay. All right. I think I talked about this, right? You can see, oh yeah, I'll go over it one more time. So because it's all in the cloud, you can see who has a file open at any time. You can reference designs across projects, and you can see basically the activity history of all of your files. So for anything you create, you can see all the versions that you made of it, and every save is a version. And you can see when you saved it. You can compare versions. You can open up any previous version. It's all there and very clear. And if multiple people are working on a file, you can see who edited it when, like in this snap here. Seeing who created it, who updated it, and then the people who updated it can write a note saying what they did when they updated it. A question: can you only share folders and files instead of the entire project? So you have to share so if you're sharing it by letting someone in your team, meaning they're going to collaborate with you on the same file, then you have to share at the project level. But projects can contain files. I can have a project with only one file in it, and I would share that project with someone. If you just want to send someone a link to your design, you can just share a public link, and then they get a link that they open in the web, and then they can download that file. But keep in mind, if you do it that way, then the file they download is going to be a copy of your design. It's not the same exact file that you're working on. So if you want to collaborate with someone, meaning that they are working on the same file as you, the best way to do it is to invite them into your project or your team. Does that make sense? Okay, great. I will show you what that looks like in Fusion in a second. Okay, we went over commenting. All right, let's talk about design and modeling for a little bit, and then we'll go into Fusion and I'll give you a little tour. So since this is most people have seen Fusion, and I'm guessing most people have seen CAD or something like that, even if it's not Fusion. This maybe isn't such a big revelation here, but just to go over it quickly. So Fusion has a lot of different modeling techniques you can employ. The one most used in engineering, at least in my experience, is the first one, parametric. Parametric design is it's sketch-based and dimension-driven design. So there are certain practices you do in parametric design, like you fully define your sketches. You have, you want to use equations or use formulas to kind of drive designs. Usually things end up looking more boxy. You're usually working in solids. Those are just kind of some commonalities of parametric design. And that's really what we're going to be talking about today mostly. But just to give you a kind of a tour of what else is there. So Fusion also has other types of tools. So I'll come back to direct, but freeform modeling is mostly used for industrial designers. It's essentially clay in the computer. So you can push and pull on faces without any dimensioning or sketching or anything like that. It's pretty wild. It's not something I interacted with in college, but you can kind of see if you play with it that a lot of the things that we touch and a lot of the products that we touch, more on the consumer product side, a lot of them were probably made with a freeform tool, or at least parts of them were made with the freeform tool. Surface modeling is also parametric, but you're making surfaces instead of bodies. You're making surfaces instead of solids. Mesh is a pretty limited workspace, but it allows you to manipulate, STLs and things like that, repair them. And then sheet metal. It's similar. It's similar to the solid workspace or parametric workspace, and it does use parametrics in the sense that you're driving things by sketching and by dimensioning, but it has a couple of other things, has a different governing rule in the way it works, so it gives you a couple different features and things like that. All right, so for anything and then direct. So coming back to direct. So direct is a way to edit your models without using sketches. So instead of changing the sketch to change a body, you would just directly edit the body by pushing and pulling on faces. So in the picture here, if I wanted to change how much this face extrudes, instead of going back to the sketch or the feature and editing it, I would grab this face and just pull it out. And it would, and I put a dimension in on how far I want to pull it out, but it's basically creating an offset of that face. And that's pretty cool. It saves you a lot of time from having to go back to sketches if you have a really complex model. Okay, now the hierarchy. So this should be familiar, but for anything parametric, you're going from sketches, 2D, to bodies, 3D, and components and assemblies. So bodies comprise components, and components comprise assemblies. So a really common question is, what's the difference between a body and a component? A body is just a continuous form. So any continuous form can be a body. This image here is actually two bodies because these are non-continuous forms. Bodies are, they're static. They're just modeling tools. They don't have their own coordinate systems. They can't move on their own. They're simply just continuous forms. Components, on the other hand, have their own coordinate system and they can move in space. And components are comprised of one or more bodies. So I can have a component with 10 bodies in it, or a component with one body in it, and that component will have its own coordinate system and it can move in space. And because it has its own coordinate system and can move in space, I can assemble it. And that's really important. So when we're working in assemblies, we only want components. We don't want floating bodies that aren't assigned to components. Any questions about this slide? A lot here. Okay.
Sounds good.
Great. All right. So there are, in Fusion, kind of two ways to build assemblies. So, right, we're talking about assemblies as multiple components. So anything you're really building in engineering is pretty much an assembly. Like even a pen is an assembly, right? You have a spring, you have an ink cartridge, you have casing. If it's one of those ones that you push the tip down, the tip is its own separate part. The thing you push is its own separate part. Even things that you think are really simple that are mechanical, they usually are an assembly. It's anything that has different components inside of it that have their own motion, that's an assembly. So there are two kind of methods to build assemblies. One is called bottom up and the other is called top down. And I think if you understand this, you are going to be a fusion, a fusion wizard someday. Um, because fusion can do both, and most CAD softwares that I've worked with can't do both. Now let's go through bottom up first, because bottom up is what people who come from other CAD softwares are used to. So as the arrows kind of show, right, with a bottom up modeling strategy, you start with components at the bottom of the tree. So you start by making components, and let's say, you have to make 10 components for your assembly. So you make all the components, and then you assemble them. So you make a new document that's an assembly, and then you put all the components that you made into that document. Now that document's an assembly. So that's why it's called bottom up, because you're starting with the individual components and then you're creating an assembly from them. So you're kind of going up the tree. And then that assembly might be put into another assembly that has that sub-assembly and a couple other parts. So you're working your way up kind of the pyramid. With top-down modeling, you're starting with the assembly and you're going down from the assembly and creating the individual parts. So you start in a new file, and then you create a component inside that file, and then you populate that component with bodies. You finish modeling. Then you create another new component, and then inside that new component, you're creating new components. So that is going to be a subassembly, and then you populate all of those subcomponents, and now you have a full assembly. So two different ways to get there, but they both are assemblies. And knowing when to use each of these methods will make you a really, really great designer. So Fusion can do both. And the key to basically figuring out when to do which strategy is figuring out how, one, are people going to collaborate on your file? Is it just you, or is it a lot of people working on the same file? And two, are you going to need to reuse parts? And three, are you needing to have the parts kind of linked together in some way? So if you need to share, if you're going to collaborate with people, so if you're working on a team of people, bottom up makes a little bit more sense, because then each person can work on their own files, and then all collaborate into a larger assembly. With top down, because you're building it all in one file, really only one person can work on it. However, top down has the advantage of you get to link everything together. So because you're creating it all in the same file, you can have everything share a set of equations. You can build parts off of each other. So you can, use sketches from one very easily in the other. You can you can extrude faces of one component and make that into a new component. So you get a lot more kind of parametric benefits to top down. And the other piece I mentioned was that in bottom up, because everything is its own file, you can reuse those files. With top down, all those things that you're making, they only exist inside of that particular document. And if you want to get them out, you can derive them into other files, but it's not its own thing. So like this component at the bottom of the tree exists inside of this document, but not separate to it. So I will do a little demo of what that looks like. And I think that's it. My last slide is usually talking about rule number 1, which is a fusionism for when we build a top-down assembly. The first thing we do is create a new component. Because we're starting that, building that tree down, we don't want to start sketching and doing all that stuff until it's assigned to a component. Otherwise, we're actually doing a bottom-up strategy. If we just start sketching right away, then that sketch exists inside, the top level, and now that file is really just a single component. So we want to make a new component first if we're going to start building a top-down assembly. So I think at this point, I'm going to pause for questions, and I'm going to jump into Fusion. Yeah. Okay. So someone asked, do you have some type of visual to demonstrate how top-down works? Yeah, we're going to make a top-down model together. Okay. So let's do a little tour of Fusion. All right, so first, first let's talk about data since I said I'd go back to it. So if I hit those 9 dots, that is my data panel. And this is where all of my data is stored. This is my hard drive. So I have all of my projects. So my workshops folder, let's say, and then under my workshops folder, I have my workshops project. Here's my projects. Under my workshops project, I have folders. So if I go to my CAD folder, I have more folders. I have a lot of stuff. I can keep going down, and then here are my files. Now, if I go into my my workshops project, I can see a data tab and a people tab. That people tab will show who I shared my project with. So this is shared with my colleague Dan. Now, I work with a lot of schools, right? So I have been invited into a lot of teams. So these are all the teams I've been invited to and I'm a part of. So if I click on the team I'm part of, this is my team, I can see I'm also part of all of these other teams. So if you are in Fusion, you probably only see your team, and that's totally fine. But if you want to invite people into your team, you would open Fusion on the web and invite them through that interface. And if you just wanted to invite them into single projects, you could do it through Fusion and just, type their name in the people tab and share that project with them. So that's kind of the workflow there. Also just want to point out the samples area. So all of you have a samples area in Fusion, and there's tons of good stuff in there. So if you want to kind of see really advanced designs, see how they were made, check out some electronics, some generative design, simulation. There's lots of things in there. You can open them and you can save your own copy and play around with them. All right, that's the data panel. So now Fusion itself. So the top bar is the toolbar. It's context specific. So when we're in a sketch, the toolbar will change to be a sketch, or to show all the options for what we want to do in a sketch. This is the solid tools. These are surfacing tools. These are sheet metal tools. And this one is ominously called tools. But here we can export to 3D print. We can use some add-ins for slicing and some other goodies and inspection things. We can add more add-ins. There's a Fusion App Store if there's something Fusion can't inherently do, and you can check if there's an app for it. Now, if we go into other workspaces like render, you can see the toolbar changes to be a rendering workspace. Same with, manufacturing. The toolbar will completely change to have those tools. All right, continuing in the design workspace for today. The left side is the browser, and the browser is grouping whatever you create by type. So it's going to group by component, and it's going to have a hierarchy of all those components. So if you look at your browser after we're done, you're going to see, 4, 5, 6 different components and all of their bodies and all of their sketches. On the bottom is a timeline, and the timeline is grouped by order of operations. So it might have redundant data from the browser to the timeline, but the timeline is recording everything in the order you did it, whereas the browser is recording everything and grouping it together by type or by organization. So different ways to see it, but together they paint a really good picture of what you're doing, and they help you find things. Okay. And there's a question. How many types of file format? Great question. So Fusion uses one type of design file, And that's why the top-down or bottom-up methods are both used, is because you only have one type of file, and it's a Fusion design file. And that file can be anything you want. It can be a single component, or it can be an assembly, and it just depends on how you create it. There is a separate file type for drawings, and I think there's also a separate file type for the electronics CAD files that you create. Yeah. Okay. So if folks are ready for the hands-on portion, I'm ready to start. So if you could go hit participants on the Zoom toolbar and then put up a yes if you have Fusion launched, you're logged in, and you're ready to go. And keep it up. Keep that yes up. Okay. All right. And then maybe an X if you don't. Someone put an X on there. I didn't quite see it. Someone did put an X. If you were the person who put an X, can you type in the chat? What happened? Or if anyone else is having issues. Misclick. Sweet. Okay. I'm assuming if you didn't hit a check, you don't want to participate in this hands-on portion. We have about half, maybe a little more. 1, 2, 3, 4, 8, 9, 10. About half. Okay. This is kind of a last call. So if you are not ready, if you don't have Fusion up and you're like not ready to go, please tell me now if you want to participate. And if you don't, that's fine. That's totally okay. But I'm gonna start. So let me know now if you need anything. Okay. It looks like no one is. Okay. One person is downloading it. Okay, 2 people are downloading it. So I'll retype the place to download in the chat. Oops. Sorry, that was actually a mistype. That was our old link. It's www.autodesk.com/education. The second one. Okay. All right. For those who are downloading, we're going to start slow so you will be able to catch up. I need to pull up my notes here. All right, so once again, I'm going to do a couple steps at once, and then I'm going to pause and let you all do it, and I will give you time to do that, so you don't have to do it do the step while I'm showing it. Okay. So the first thing I'm going to ask you to do is something that I know you're all in Canada, so you will hate me for, but change your default units. Sorry, don't change your default units, but change your units to inch, just for this this file. So if you go in your browser, so watch me. If you go in your browser under document settings, there's a units. And it's in inches. Well, mine's in inches, but yours is probably in millimeters. If you hit that change active units button right next to it, you can change your active units from yours is going to be millimeters, change it to inch. Now, when you change it, it's going to ask you if you want to set it as default, which I assume you all don't want to do. So you don't have to set it as default, but that will just change the active units for this document. All right. So that is one thing, and I'm going to do one more thing, and then I'll pause and let you try it. The second thing I want you to do is save your file, and you can make a project. You can make a folder within a project where you want to save it. And so I'm going to call it adaptive bracket UTDL. Okay, so I'm going to pause and let you all try. Hit your green check mark when you are done with those two steps. So changing your units and saving. Nice. Now wait another minute or so. Okay, 3 of you are done. 4. All right, great. Okay, I think that's pretty good. All right, so the next thing we're going to do is create a new component. So we're going to do a top-down modeling example with a couple bottom-up components at the end. But we are going to create a new component first and then we're going to populate that new component, and that's going to be the start of our top-down. So under create new component, it's the first one. You can also hit new component under assemble. It's the same button in 2 places. So we're going to make a standard component that's internal, and that's the top-down model. If we wanted to make an external component, it would create an external file that references in the code design. This is kind of a way to do the bottom-up model inside the same dialog. So ignore that for now. We're going to stick with internal standard component. The other option would be sheet metal. And we're going to call it bracket. And the parent is going to be automatically selected to be whatever component is active, which active means it has the target next to it. And the only component that's there so far is our top level file. And you'll notice it has a single block next to it to signify right now, before I make this other component, it's a single component. And as soon as I hit OK, it's now going to become multiple blocks to signify now this represents an assembly, and we have a component under it called bracket. Okay. Next, before I let you all try it, we're going to create a sketch. Now, when we create a sketch, it's going to give us an option to pick a plane, and I'm going to pick this bottom plane that's parallel with the top. And it should snap, but if it doesn't, I'm going to hit look at, and then it's going to look at that sketch, go normal to that sketch. And I'm going to create a center rectangle on the bottom, on the plane, hitting the origin as my starting point. And I'm going to click to place it, and then I'm going to dimension it on one side to be 2 inches. And then I want to make those sides equal. So I'm going to click the equal constraint on the top and click 2 sides, and they will now become equal, and all the lines are black. Black lines are what you want. That means that the sketch is fully defined. Okay, so now I'm going to finish that sketch, and you'll notice that that sketch now is contained within the bracket. So I'm building out the bracket, and that's what I want. So I'm going to pause there and let you try it. The things that you do first, you create a new component, call it bracket, and then create a sketch on the top plane and make it 2 inches wide. And I will put a slide up that gives you all of those instructions. 2 inches square. 1 second. There you go. And if you have any questions or you want me to do a specific thing again, I'm happy to do that. And of course, I'm going to clear your thumbs up. So put another yes if you're done with this step. Oh, we didn't do the last one. We'll do that on the next. We'll do that on the next step. Is extruding the square 0.25. So don't worry about that last step. Just do 1 through 3.
I just had a quick question.
Yeah.
So I thought for top down we shouldn't sketch. Is that wrong? Or
you should not sketch first. So with top down, you want to create a new component first. And then when you sketch, it's inside of that component versus just inside the top level.
Got it. Okay.
In top down, you always want everything to be assigned to a component because you're building things as components. So as long as you create a component first, you can continue to make your parts the same way you would.
Mm-hmm. Thank you.
Yeah. This is a top-down assembly. So top-down, we start with the assembly, and then we go down to the smaller parts, and that's what we're doing here. We started with the file as our assembly, and then we're creating all the parts inside of it. Lucy asks, how do you make them equal length? So on the top bar, when you're inside the sketch, there should be a bar called, or a section called constraints. You can click the equal constraint. I'll show that. So when I'm inside the sketch, to get back in a sketch, you just right click on it on your timeline and hit edit. You'll see this constraints section, and you can hit equal and then select the 2 lines you want to be equal. Okay. All right, so yes, icons on the participant list if you're ready to move on. And if you are ready to move on and you don't want to wait, you already saw the next step. So you can try extruding it 1/4 inch. So extruding it 0.25 if you want to go ahead. For those who did not put their yes check marks yet, any questions or something you want me to redo, or any confusing parts? The most important thing is you made a new component first, and you're populating the sketch inside of that component. Yeah, great question. What are we building? I mentioned it really briefly at the beginning, but it's fair that you might have missed it. So 1 second. Great question. This is what we're building. A little bracket assembly to show you. Yeah. All right. Can you show us a slide with steps again? Yes. Okay. All right. So only design, no automation. Jod, can you expand on what you mean by that question?
Yeah, like, is it gonna be like a mechanical product that's like connected to, like, how would I say it?
Like
Yeah,
that has
is it
motion?
only designing or yeah.
Yeah, we're gonna add motion.
Okay, well, thank you.
Yeah. All right, and then Lucy asked, are we gonna learn how to add the colors and make it shiny? Yes, hopefully we'll get to all of this. How are we doing on time? Yes, hopefully we'll get to all of it. We're probably not going to get to all of the components so that we can do some of those bells and whistles. All right. Still only 5 people have said that they're ready for the next step. But I think we do need to move on to get everything covered. 6 people. Okay. We had 10 for the last step, so I think we lost some. Any other questions from folks who didn't put their thumbs up yet or didn't put their check marks yet? Okay, no, 9, great. All right, I think we're ready. So next thing is to extrude that base. So we're going to hit the extrude command, and we're going to extrude it 0.25. It's going to automatically select the shape. And as soon as I hit OK, I now have a body. So I have a body and a sketch. So that's great. That's first step. All right, we're going to add another feature to this. So I'm going to do this next slide before I stop and let you all try it. So we're going to create a sketch. Oops, 1 second, sorry. Going to create another sketch, and we're going to select this front plane. Okay, so the front plane here. And we're going to make a shape that is 3 rectangular sides and has an arc at the top. So I'm going to do a 3-point arc, click the 2 points, and pull that arc up. So this is not, I want to kind of clean this up and put dimensions on it. So we are going to make this line vertical if it's not already, make this line horizontal if it's not already, and we're going to make this arc tangent with this line. So that's the tangent constraint. Okay, and then we're going to add some dimensions. So the radius of this is going to be 0.75, and the length of this line is also going to be 0.75. And then at that point, sorry, 1 second. My bad. The radius of this is actually going to be 0.375. There we go. So the radius is half the length of this line. And now it's all dimensioned except for the fact that I can move it around. So I want it to be in the middle of this. And the way to do that is to use another constraint called the midpoint constraint. And that midpoint constraint is the triangle. So I'm going to click these 2 lines, and the midpoints of each of the lines are going to snap together. So I click the midpoint constraint, click one line, and then click the other line. And now the midpoints of each of those snap together, and it has fully set itself in the right position. Okay, and when you finish that sketch, you will exit out of it. And I'm going to stop there and let you all do that. So hopefully it'll be quicker. So green check mark when you're ready and done with the step, ready for the next step. So the two things I did were extrude it 1/4 inch and then create this sketch on the front plane. Okay. Fernando asks, sorry, having computer problems. Are the slides going to be posted somewhere? Yes, I'll send them to Sahar. Okay. Sweet. One person's done. I'm guessing this person, Mark, you must have 2 monitors or multiple screens. Yep. And yeah. So if anyone wants to try the next step while we wait for the group, what we're going to do is extrude this profile, but from this side inwards and then mirror it on the other side. So some tricky but cool 3D work. Oh, let me show that. Sorry, everyone. Here we go. That's the instruction. Okay. Yep, and continue to put that check mark when you're ready to move on. Cool. Cool. 3, nice. Nice, 6. When we get up to 8 or so, I will keep going. Anyone have any questions who is on this step? 7. Okay. All right, I think that's pretty good. All right, let's keep going. So the next step is to extrude it. So we're gonna hit the extrude again, but instead of extruding it just from this plane, we're gonna start at a object. So start from object, click here, click on one of the sides, and then we're going to extrude it. Let's see, what does it say? Negative 0.375. So oh no, sorry, not negative, positive. So we're gonna extrude it from object 0.375 inches. So I will put that slide up when you're ready, but start from object 0.375. Okay. And then what the next step is to mirror that object. So create mirror, and we're going to mirror that extrude feature. So I'm clicking on the extrude feature in the timeline, make sure the type is feature. I'm mirroring it about this plane, and now I have an identical feature on the other side. So I'll pause there and thumbs up when you're done. I just cleared all the green check marks. So. Oh, Lucy, it's totally fine if you built it on the wrong planes. I would say don't worry about it for now. You can like reassign sketch planes, but as long as the model is right, like it's totally okay for the purposes of this exercise here. Okay, do people need the instructions for this one? So extrude the profile from object, and the object is this side. I'll add a little insert shape. So the object would be this face there. So from object, and then extrude it out 0.375. This is slightly differently done. Okay, and yeah, thumbs up when you are done. Okay, sweet, 3. And yeah, please ask me questions if you missed a step, you want me to go over the mirror or the extrude again. Maybe I'll pull up that extrude one more time. So I'm going to go back in and edit my extrude to see what I did. And I did from object 0.375 inches, and I selected that sketch.
So sorry for missing this, but could you please show us how to do the mirror again?
Absolutely.
Thank you.
Yeah. So you go to create mirror. And then in my mirror settings, I selected features as the type. And when I selected features, I can either click on this feature or I can click on the feature in the timeline. And then I mirror it about this middle plane that'll show up. And then that's it. Yeah. Yep. So for those who are done and want to try the next step, and then I'll go over in a second, the next step is to add some holes. So the way to add holes is you use the hole command, and you can snap the hole command into this. You can use the hole command to snap the hole to the center of a circle, so that way you can easily get it into to be concentric with this arc of this bracket. But the trick is that you want to end up mirroring that hole, so you have to roll back the timeline and then make the hole, and then roll the timeline forward and then mirror the hole. So I will go over that when we are ready. But if you want to try it, feel free to. Okay. I think we're at almost quorum here. So next step is to add a hole. So I want to add a hole, and then I eventually want to mirror that hole. So I can roll my timeline back, add a hole, and then I'm going to snap it to this face. And you'll notice if I make it a little smaller, if I try to drag it around, it wants to snap into the center of that arc. So that's helpful. That's where we want it to be. And I'm going to make it 0.51 inches wide, or diameter. And I'm going to have it go to the other side of this. So it's going to cut through the feature and be 0.51 inches diameter. So once I'm done with that, I'm going to roll my timeline forward. And now I'm going to edit that mirror. So right click on the mirror, hit edit, or double click on the feature. I could also double click on it to edit it. And now when I select my objects to mirror, I don't just want to mirror the extrusion, I also want to mirror the hole. I'm going to hold down Control, and I'm going to click on the hole in the timeline to add the hole to what I'm mirroring. And now when I hit OK, both the hole and the other feature will be mirrored. So I will let you all try that, and I'll put up a slide to show that step. So hole, select the front place, center the hole, and create a So I will go through that one more time. So what I did first is I rolled back the timeline one. I added the hole, and then I rolled the timeline forward and edited the mirror to include that hole. So the purpose of me doing this is to show you that you can play with the timeline to add features in the locations that you want, and to also show you that you can edit your features and change them at any time. Okay, I'm not seeing anyone done yet. So if no one's done, do people have questions about what I did, or they're just lost, or they want me to explain a step? Please let me know.
Sorry, is the diameter 0.51?
Yes.
Got it. Thank you.
How can you resize the hole if you made the wrong size? Great question. So you double click on the hole feature, or edit, or right click edit, and then you go into the place where you enter the diameter, and then you can change the diameter. I'm having trouble adding the hole to the mirror. Okay, so in the mirror, you want to hold, so if you just select one feature, it's not going to let you select a second feature unless you hold down Control. So hold down Control, then you can click on the hole as an additional feature, and then you hit OK. Does that help anyone?
Sorry, just to clarify. So
Yeah.
so like you were trying to demonstrate the advantage of rolling back the timeline, right? Because if I do this before I mirror it, then it would appear on both sides. Am I right?
Yes.
So,
yes, exactly.
Okay, I see. So yeah.
Yeah.
That's amazing.
Yeah, so a lot of the benefits of the timeline are really seeing what you build and the order you build it, and being able to pull back the timeline and edit things, and then pull it forward and have the entire timeline rebuild with those edits is really powerful.
Yeah, I can, like, I mean, this is simple, but I can see that. Yeah.
Yeah, so
It's
like,
really...
don't follow me, but just to show you, if I go and edit this original sketch and I make it 4 inches, now I can update the entire model, then that'll change. So that's the purpose of, showing you that you can use the timeline, roll it back and forward, and change your design parametrically. Okay, so we are running out of time. There are more things to do on this model. One of them was fillet, so adding fillets to each of these edges. What was, I don't remember what it was, 0.5 or something. And there were other ones as well, like making multiple components, and then you'll have multiple components here. So because we're running out of time and I want to leave some time for showing you other things in Fusion, I'm going to stop there, but I do want to tell you that if you go into the samples folder, workshops and events, and you go into education and then design, so samples, workshops and events, education, design, you can see that there is a bracket and pin modeled. So it's exactly this with joints applied. So, now it is a fully done assembly. We can see that it's top down, right? There's two components here. We can hide the pin. We can see, a fairly similar thing to what we did. We can see that there was a joint applied. So a joint is motion. I'm going to one second. Let's figure out which joint was which. Okay. So I'm going to edit that joint just to show you, and I'm going to make it a revolute joint. And now that can move. This is a little bit hard to see because it's circular. So let me just quickly make it so that it is a little bit easier to see when it moves. So if I make a little hole that's off center, now when I move it, you can tell that it's moving. So that's kind of the end goal, and I will send you this PDF so you can make your own bracket assembly and finish it. But I did want to, someone asked about appearances. So we'll bring that back so we all have the same model. So appearances. So if you go under modify appearance, or the keyboard command A, you can drag any of these appearances onto your part. So any, like paint glossy, maybe I want to make it green. And now it will be a glossy green, and it's not going to really show up in all of its glory until you render it. But in this other one here, this is, let me actually save this as, so if anything you have in the samples folder, you have to save as your own copy to be able to edit it. So I'm going to hit save as. Now it's my own copy. I'm going to do the same thing, modify appearance. I'm going to make this glossy red, and maybe I want the this to have a glass look. So I'm going to make it like a glass blue. Maybe it's a blue pen. So that's pretty cool. Some of the wood appearances look really, really nice. So yeah, so that's the appearance portion, and it's pretty nice for rendering. Now I want to note that appearances are different than material properties. So if you're running a simulation on a part, you want to assign a material to it, and that's under the physical material dialog. So I can assign, something to be physical material of steel, but still have a glossy finish, so that the appearance will override the look of the part, but it'll still retain the physical material that you assign to it. And then rendering, if you want to render your part, you go into the rendering workspace, and now you can kind of see that it's shinier and takes on a different appearance there. But one more thing in the design workspace here that I wanted to note was, I wanted to talk about the top-down versus bottom-up. So we just did a top-down approach, right? We made a component, we populated that component, and then we eventually, if we had time, we're going to make multiple components. Now, the bottom-up assembly type is when you add a part into the file. So in the same samples folder, so samples, workshops and events, education and design, you'll see a Clevis pin modeled. If I right click and I hit open, I would have to save this as my own copy. So let's save as. Now I'm going to go and find that saved as Clevis pin. I probably have a bunch of things named Clevis. Okay, yeah, 3 of them. I'm going to right click on the one I just saved and hit insert into current design. Oops, this one. Insert into current design. And now I have a top-down part in my bottom-up assembly. So now this is kind of a mixed workflow, right? Some parts were designed top-down and other parts were brought in bottom-up, and that's totally okay. The mix of these workflows is really what kind of makes it unique and makes it really powerful. So once I pull that in, I'm just going to move it aside just to show you. And now I want to make a joint. So a joint is what assigns that motion. So if I do assemble joint, continue, I want to join the middle of this pin with the middle of this bore. So I'm going to hover on this face, hit that middle point, and if I hold down Control, I can see that I can go between the edges and the middle. So I'm going to click that middle point right there, and I'm going to join that with the middle point of this pin, and I'm going to do a revolute joint. And if I wanted, I could also do a cylindrical joint, so it rotates and it moves side to side to give it 2 degrees of freedom. So now if I pull on it, I can rotate it and pull it across the pin. And once again, can also assign a physical material and or an appearance to it. All right, Lucy asked, so you can have it set as wood, but make it look like metal. Yes, so you can have it be assigned to be wood and then have the appearance be metal if you want to confuse yourself and make it look cool. So yeah, I encourage you all to look in that samples folder to complete this, and I'll send you the tutorial so you can do it. Sorry, we ran out of time, but yeah, that's all I got.
Awesome. Thank you very much.
Yeah.
Great presentation.
Kyle, I lost you.
Oh, can you hear me now?
Yeah, there you go.
Yeah, so thank you very much. That was great to learn some new features and functions of Fusion 360. Thank you very much for taking your time out of your day and running this workshop with us and for us.
Absolutely.
And then for everyone who has participated and stayed for this workshop, I'll be sending in a Google form in the chat link to allow participants to enter in their email for a chance to win an Amazon Echo. So I will be, I'll send that in the chat right now. And as usual, the workshop will be able to be found on our website and on our YouTube channel.